everybody and welcome to another video. Today we'll be continuing the C++ integrating with Stb headers, C headers video where we have created a wrapper to keep the rest of the C++ database consistent with the C++ RAII. But we've missed a crucial factor and crucial portability that needs to be made in order for this header to be usable, even functional or usable or even legal to use in terms of CPU execution, in order to avoid all the memory leaks and all the segmentation dump errors as well at runtime. So that would be the reallocation of the header, of the rather buffer, and the cleaning up of the buffer. So you can see that we are using the realloc and we use free. Now realloc is kind of strange in my opinion from this Stb library of C, and that is because it is OS specific. 100% OS specific. As you can see, it only takes the previous pointer or the old buffer and the size of the new buffer. Well, you may be wondering, where is the size of my previous of my old buffer? Well, that is really up to the OS implementation. You can see that one person tried to re-implement the realloc, and then they still end up using the malloc size to get the size of the pointer, because there is no explicit way when we are calling this function to specify the size t of the old pointer. So if we look at this page here, this is OS X specific. So yeah, that is the first obstacle that we will run into when we are sort of making this portable to C++. But let's first understand the semantics behind the implementation of this header in C. So I made sure I removed the rest of hash table implementation from this header. So although I didn't clean up these macros, I did clean up most of this file. So we are, just for the purposes of simplicity, so we get up to speed to what we're doing here exactly. So if we take a look at this, you'll see that this is an array that's being constructed of a header and the actual buffer that holds the items or its elements. So it took me a good few hours, I would say, to make this portable, and I jumped straight to modifying the C code without having that much background in implementing these kind of arrays, where we first have the header of the array, which holds the metadata of the buffer that can include the length, the capacity, etc. So if we look up the definition of this struct, you'll see that we have length, capacity, hash table. This is used for hash tables. And we have the temporary, which I'm not sure why we're using. It's probably for hash tables, but that's neither here nor there. Um, so let me get back to the header. Okay, so then I sort of took a step back and looked at how do I do this in C++ exactly. If you haven't checked out the video Advanced C++ Memory Allocation, do so, where I'm walking the audience through how not to use, because it's C++ after all, how not to use malloc and calloc, because it is truly obsolete in C++ standard, and it can cause all sorts of errors as well because of C++ RAII semantics. And I made this comment in this article that says, okay, just use malloc and the memory just use malloc of your OS and calloc and you'll be fine. But no, that's not gonna cut it at all. So I made a certain comment where you can accomplish the same thing where, and the reason for this article is that if you allocate an array in C++ like this, it will, or actually on heap, my apologies, it will prefill all the data in that buffer by calling all of the constructors of S. And that is a requirement in C++ just to make C++ semantics work and to avoid undefined behavior. So in order to not call or implement a lazy array on heap, you would need to use the operator new, and you have to access it like this so that there are no overloads in the current file. Or you could approach it by reinterpreting the cast to your respective type, where you will first allocate the character, and rather the unsigned character. I'm not sure why I'm using character here, but that's fine too. But if you unsigned, let's use unsigned character. Let me just compile that real quick. So yeah, I would be using unsigned character there, but you can use character too, so there's no problem with that. I think they're both, by the way, the size of 1 anyway. So size of unsigned character. I mean, this is probably the kind of stuff I should know off the top of my head. But yeah, they're both 1 as per my assumption. So anyway, that's how you would allocate your lazy piece of memory on heap. And that's ready to use so that you don't call all of the unnecessary constructors when you don't need to call them. But the only sort of bottleneck of this, or handicap, is that you will need to call your destructors explicitly upon your or before your delete, because this delete will just clean up the buffer. It won't clean up the elements of it, because in if you are not using primitive classes or primitive types, you will need to explicitly invoke your destructors in order to clean up uh, the unnecessary data or the unnecessary elements. But we are not using explicit destructors here. I will explain that in a moment why. But that's the brass tacks of how to use reinterpret cast in order to accomplish lazy memory allocation C++ without using malloc or realloc or any kind of stuff that's really obsolete in C++ for many reasons. So how would you create a header of an array and still use that buffer for its elements? You would take the size of the header and the size of your elements. So I'm allocating only one S here, but if you want to allocate more, you would do something like this, 100. That means that you have the ability to initialize the header, which will be at 0 index, and the rest of them will be at starting from 1 to 100. So yeah, and it will be 100 because now our array is now 0 indexed per se. And then I would first construct my header via a new placement, which is going to hold my array metadata as I've explained previously. And then I'm going to do reinterpret cast, or I could have done it before that, where I will set the length of my array and stuff like that, where in this case we'll just go with 1 because our array is definitely just 1 in this case. And then what I'm doing here is how am I gonna allocate or place my S? It typically would be to take the size of the header and go with your index. And that's pretty much it. Or you can just take the interpret cast and take your character pointer, and do plus size off, because you need to consume or advance ahead of that header so that your elements are usable at this point of memory. And now if I verify that, I'm getting 13, which is what I created or initialized here. And then upon which I will have to, because this is where I've reached the end of my scope, and I can either wrap this into another class where it will be called implicitly, but for the purposes of simplicity, I kept it here. So yeah, first you would call the explicit constructor of all of its destructor of all of its elements, and then you would finally free up that new character memory, and that will work just fine. Now let's get back to how to implement reallocation in the Stb header. So Stb header doesn't have malloc or anything like that, it just has realloc. That is because each time we try to place something in the array, and make sure to check out the video integrating C++ with Stb header, or integrating Stb single file header with C++ to see the meaning of this array push new place. So each time we would try to push an item onto or element onto our array, we are going to check for if the array is going to grow or not. And now if we track down this function, we'll see that it leads us to here, where if C++ implementation, or we are using C++, we are going to call this function. And this is pretty neat from the authors, and I mean, everybody would appreciate this, because now in C++ you would need to pass around that T type, because now it is not low level implementation in C where everything just magically works with greater understanding of your OS headers. But now you get to pass around your T type in order to write your realloc. And you also gotta appreciate, by the way, the fact that these realloc headers were defined as C, P, and S. C would represent the context, but what I read above, P would represent the previous buffer or the old buffer, and the S would be the size of the new buffer that you're trying to create. And I really appreciate the fact they put in C in here, because now you can have your context object, but I use C as the size of my old buffer because I need it. And that's how you would, and because we are not using the OS specific C header realloc, we will need to have the size T of the old buffer. Now if we scroll down to the, okay, let me just get back to here. Now if we track down the definition of the Stb Ds array grow, you'll see that we first try to get the array length, although I would just to avoid calling this twice, let's just do length here. And let me just check if it'll work. Sure. So yeah, first we'll get the array length, and here we decide when are we going to grow or reallocate our array. And that depends on the capacity factors here, and there is the logic. But the important thing for us is the calling of the realloc. So first, when you include your STB header, you would also need to overload, and you will need to define both of these, because that's what the header defines you to. If you can't just define one of them. If I try to define one of them, oops, that's the wrong terminal, I will get the compile time error where you must define both realloc and free or neither. But then you will be relying on OS specific realloc, which is not going to work with C++ RAII once you realloc your buffer, because you need to make sure you reconstruct everything if your array doesn't, or your struct doesn't just hold primitive types. If you have something like this, you have to have this to work. And you can see my note here, I did this for Stb Ds reallocation testing purely because it just doesn't work if you don't do this kind of stuff. Or you want to test how, if it works. So you gotta go all in and make sure that everything is covered. So now, because I managed to pick up my type T, and I needed to add additional argument to stb realloc macro, because I cannot pass around T in a macro, I can probably do type off or decal type, but I'm not a fan of that. And if this previous buffer is a null, I won't be able to determine my type. Even though if it's not a null, I can probably do something like this. But if it's null, then we are pretty much cooked. So my realloc works like this. I have a character array, which I just talked about in a moment, which I just talked about while I was explaining that article comment. And now what I'm doing here is I'm trying to skip the header because that header needs to stay there. And you may be wondering, and it's kind of confusing when you look at it, because each time we are trying to look for our STB array header, we are gonna try to do a plus of the size of that header. But if you look at when we are getting the STB header, we're doing a minus on it. And then, but before that, we're doing an Stb Ds array reinterpret class. And that is essentially the same as this. It's just this is more C++ friendly in my opinion. Why we're doing -1, I was kind of perplexed by this as well. But then I figured if you look at the definition of the realloc, you'll see that we are first skipping the array header, and then we are trying to initialize all of its elements, and then we are and then the capacity, and then we are returning B. So we skipped to the point where we get to our elements of the array. So then once we pick up our array, we will cast to the header itself, which will make each element sort of like array header, but it's illegal to access them. But the first one, which will be at the 0 index. So if we cast, if I go back over there, once we cast to this, our array will be just our underlining type array. But still, how do I get to the point where I get the header? I cast the entire array and I go -1 on it. And then I'll access the header. And that is just because this function already skips to that point. Or this pointer increments to that point in memory. So that's how it works. So you have to make sure once you're building your realloc, you have to make sure that you return a character pointer that points all the way back to the creation of the array itself, and doesn't point to your elements or your old elements, nothing. It has to point at the start of the literal start of the array. So what I'm doing here is I'm just to save up some work so I don't have to do this, size of t. So I'm doing a cast here where I'm skipping the header, and then I'm able to move all of my previous elements. Why am I moving all my previous elements? I don't need them. And because I'm moving them, that's why I don't need explicit destructors here. Because all of my elements within that um, entry are now moved. I don't need to call a destructor at all. And make sure to check out C++ Hacking Destructor series to understand why we don't need to call destructors if we are 100% sure that we are moving a variable into another piece of memory or another entity. So now this is really crucial for us. If I comment out this section of code, we'll get into a lot of trouble. Why is that? When we are reallocating the buffer, that will copy all of our elements or move all of our elements into a new buffer, we also have to make sure to move or copy. In this case, copy is fine, right? Because this array header is just a primitive header, really, or a primitive struct that contains size t, size t, size t. It doesn't have anything that depends really on C++ RAII. It's fine to do a copy, because essentially if you do a move here, that really equals to a copy, because it is just a primitive. And it will work, of course, but it's still just a primitive, so that is really redundant there. So I've gotten my previous header, and I'm doing a +1 here. Why am I doing a +1? If we look at when it's our C++ reallocation called here, I am trying to get the header. And when I'm getting the header, I will be doing -1. So -1 will get me to the header itself. So in order for me to get that header, I will need to do a plus again on the old, or actually I got lost here for a moment. I'm doing a plus on the old because the array header here is at the beginning of my array. That includes the header itself. So I need to do plus on the old, +1, where I'm already having the header, and that means I skipped the 0 index header, and then I can cast to my respective type and move all the old elements into a new buffer. And in order for me to copy the header into the reallocated piece of memory, I would just access it by 0, because at that point it is at 0. Or I can just do something like this as well. I can just dereference it because it points to 0. And that will work just fine. Now I'm using all the possible options and settings here in Valgrind, because I'm trying to detect all kinds of leaks, and like I said, this gave me a lot of difficulty in order to have this fully portable to C++. So I did track origin yes, check, leak check, and I was looking for any or all the kinds of leaks. So yeah, we made sure we copied the header, and now we get to the point where we need to free all of our memory. And how do we do that? We will just call delete. You can also you can also prefer this. It just depends what kind of practice you're rolling with, but this all works. I would just pick up the previous old, and because it's already at the point of 0, because I'm accessing it, the header here, I will just invoke delete with the brackets, and like I said, you have to make sure to use the colons here so that you're using the built-in operator of C++ in case it gets overwritten or overloaded in your file. And then you would just return the beginning of your character buffer, and then we're gonna do our we're gonna do our magic here, where we have to skip the array header and return it, and now it's fully ready to be used. As we are doing a casting in here, so when you determine if your array will grow, you'll see that there is array assignment. And if you look at the code replaced at the preprocessor level, you'll see that in here, once we push our elements, we are essentially doing something like this: realloc, C++ realloc, which will be S, and then it'll take all the arguments, but I will redact them rather, and this is where you would invoke your new placement. This is where you get your header, and header, then you do the length, and then you do your typical S. So this is what roughly, I mean really roughly what it would look like at the preprocessor level once all the macros get replaced. So yeah, we've got that to work pretty smoothly, and I'm gonna upload this source code as well, where I'm also including the source code of the previous video, where we're trying to create a wrapper for our Stb Ds array. All right, that'll be all for this video, and yeah, till next time, take care.